The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The broadcast is now starting. All attendees are in listen-only mode.
Good evening, everybody. First of all, thank you very much for joining me in this discussion. And I very much request you to just stop me whenever you feel like and clarify any of the doubts or raise any queries or anything like that. Let it be an interactive discussion more than like a lecture or anything like that. So we are going to talk about the students' projects, especially in the engineering students' project, the end semester projects, or a final project what the students are going to do. And I hope most of the target audience who are listening this are some sort of faculty or some sort of associated with engineering colleges. So we all know that the engineering student project, end semester project, for allowing them to do for the whole 6 months without giving them any other subject load or anything like that, is mainly to exercise what they have exactly learned and how they are going to mold themselves of what all the tools and techniques, tips and everything required for their career. So that's a very important learning need for the students. And as teachers, we have got a fantastic, phenomenal responsibility to ensure that their learning need is satisfied and their curiosity is kindled, and they would become better engineers. So we sow the seeds, as I put in the last line, for the better engineers coming out of in our country. So what I would like to do is not beat around the bush of the same thing what we all know, but a few ideas what I have been able to do for the past few years. So what we have to look at is not a small independent projects which these kids do, but instead we can take a large picture and we can take a problem which would probably take 2 years or 3 years to solve, and then break them into small components of 6 months each, and probably allow incrementally the students to take part in it, participate in it, contribute, and then you can have a big picture at the end of 3 years or 4 years or whatever is the time, depending on the problem which you have taken. Instead, what the trend right now is, what is happening, what I can see or what I can hear from around the engineering colleges in my state. I mean, there are quite a few engineering colleges in my state, which is Tamil Nadu, happens to be Tamil Nadu. So what happens? Students just go browse around, take their previous students' batch of work, and then do some sort of face off, change the names, or do some sort of very incremental or very some silly extension to whatever has been done, and then again submit a big report, maybe a few pages, 50, 60 pages, and then that's the end of it. Of course, there is going to be review, there's going to be a viva voce by some other engineering college faculty, but all this seems to be done without any kind of a spirit or what it has to be done, but just like a work which needs to be completed, and you just to get a minimum thing for your degree. But unfortunately, what I would request or what I would look at is, let we as faculty take it as a big picture, and then try to take incremental small work get done by these students, for which not only the students must be willing to accept, but even our organization, our universities, even our academic councils, they also must look at this in a bigger picture and accept small increments on the project. So that's what I would like to take. I mean, at least you can start up and look at it. And another most important aspect, which many of them know, which is a big barrier, is how are we going to fund such a big project which is going to extend for 3 years or 5 years? Do I put it from my pocket, or definitely my management or my college is not going to do it? So how do I go? That puts a barrier and stops you from thinking really big, or thinking some very, very essential social problems to be addressed, which is relevant to your field or to your discipline. But I would like to bring to your notice that there are entities like PRISM. Probably most of you might have heard about it. It's an initiative by DST, Department of Science and Technology, wherein you get funding up to something like 75,000, 1 lakh, specially for students' projects. And then there are organizations like BIRAC, Biotechnology Industry Research Assistance Council. What they do is they take up even huge, bigger projects and fund you even up to 30, 40 lakhs even, provided your project or your idea, your student project aims at coming out with a product, coming out with a solution to an existing problem which you can prove, instead of just ending up in some sort of an IEEE paper or some very fancy work which is what being expected out of end semester projects. Not very many people, at least at the UG level, expect something like bringing out presentations and this, but that has been the norm for PG as well as PhD student projects, who just, if you are able to submit some 3-4 papers in some refereed journals or even many other journals which are proliferating these days, online journals, there ends the matter. That is the end of your project. And unfortunately, this is not the case with a very small engineering college which is privately financed and have a few hundred students, or a very huge university, governmental or private, deemed university for that matter. Still, they are all running in the same rut, which just you publish some papers and there ends the matter. You don't worry about your report, or anybody else sees that report. It's a big waste of time of everybody else. So instead of that, what I would like you as teachers to ensure is you put the focus on product. It can be very simple. It can be a small sensor addressing a particular very small problem, or it can be addressing a survey which is going a traffic engineering survey, which is going to help somebody to come up with some sort of a solution. It can be very, very simple, but still I would say that gives you phenomenal experience as a student and as a teacher, whose your horizon will improve if you keep thinking on these things. And that's probably what exactly expected out of you teachers, provided to your students. Mold them or give them the proper direction, like what are the problems existing, how it can be addressed by technology, how it is relevant for them to provide, think about it, dream and bring out solution. These are the some things which you would like to inculcate in your students at least. That's what I talk about when I say motivate students to take part in contests. Today I see, maybe past few years, there are lots of contests being conducted by many deemed universities, many colleges, annual events, or so many contests. And so what I would request or what I would suggest is you motivate your students to ask them to take part in such contests. Of course, the time window allowed for you is very small. This is 6 months, but you need to really start maybe from the 4th year, or maybe even from the 3rd year, if you get a very, very interesting and very hardworking set of students, where you can establish a rapport. And it's not just the last 6 months you worry about some sort of an output to be produced in terms of students' projects. So as a teacher, what I would like to say is you have to walk the extra mile, think about so many projects and so many solutions to existing problems, what you have in your relevant fields, which is very much applicable to in your areas or in what you can think about, and then line them up for your students so that they will be able to select it. Sir, I will work in this project. Sir, I will work in that project. I'm interested in doing this. So you can give them more inputs only if you have done your homework, if you have created all your problem statements, if you have Googled about it, thoroughly researched about it, and then offer them to students so that these kind of meaningful dialogue or exchange can happen in terms of students' projects. And today in the online world, there are so many platforms which are available for mentoring, which are available for supporting you. If you can say, I'm in a very small town or a very small village, I don't have access to like people like you who are in Chennai or Mumbai or maybe in bigger cities. So what do I do? There's, you don't have to worry about it because you just open your online world. You, all you have to do is just seek and just get the support from people who are willing to offer it to you in terms of projects or in terms of any guidance or in terms of mentorship. So I would like you to first of all go through, become aware of what are the support available, and then open it up to your students who will in turn catch it up and take it forward. That's the only way these promoters, these people who are offering support is willing to do, and you are supposed to take it as a catalyst and then get it your students down the line. And there are so many websites for students project. After you complete or after you take up to a certain level, you can publish it in some, in terms of SourceForge, if it's a computer science programming project, where it's going to be useful for anybody who is further searching. So you contribute to the whole let us say ecosystem there, wherein what, even if it's a small work which is done by you, it's going to matter, take it up to the next level. So basically we are all trying to sow seeds in terms of project ideas, in terms of project implementations through students projects, and definitely there's going to be a lot of very patient monitoring care, and I'm sure the results you can see only in a few years. It's not just 1 year or something like that. So be prepared to do that, and we must also be prepared to do that by doing all our homework in terms of all the resources getting collected. And we should probably suggest the students that these are the projects available, these are the areas which I'm interested in, I would like to guide you. You pick up any of these, and it not only just ends there. I'm sure there will be a lot of very imaginative and individual students who are very bright, who will come up with some ideas. On those ideas you must be able to work, get them the resources where it's available, and then show them these are all the resources available. For example, somebody wants to do a drone, which seems to be very popular these days, a helicopter or something like that. So you can add, you put a small camera onto the helicopter and see, whether you can capture it. You can do a while. So now this becomes not only a hardware guy, some sort of a computer science group also has to mix in, who will be able to take care of uploading and downloading the video information from the camera. So basically it is like a multidisciplinary, where you can involve your colleagues from other disciplines and other departments and make it big, and then offer small chunks to individual students of different departments, and collectively bring it out a meaningful or a very useful solution for the particular problem which you have taken. Am I going very fast or is it fine?
Yes, sir. It's fine, sir.
Okay. So a small tips which whatever I have gone through. Now, very simple basic thing anybody can do is, there are a lot of articles which are coming on as new innovations which are found in science, engineering, technology sections of different magazines. For example, I took the example in Hindu. In Hindu, probably on Wednesday or somewhere, I believe, Tuesday, I believe, you get a full page wherein a lot of innovations in engineering and technology are coming out. So you as teachers need to keep it abreast. So what is going on, what can be possibly taken up by us, by our students, by our community, and then contribute to it, is what something you have to always keep on the lookout, which I always do. And encourage students to tell the real life problems. Like for example, simple as I told you in the previous slide, you can take about problems in traffic. How do you manage the traffic? What are the kind of solutions which you can give them? What about automatic traffic movement, and so on. And of course, there are a lot of RFID based parking systems where you find out which is this free slot, and then try to make it smoother, so you make it people's lives easier. And of course, toll collection, where people need not have to wait hours together on weekends, especially, whereas you have some sort of an RFID or something like that, which will automatically connect it to a payment gateway, will get the toll from the car and then just send it out faster. So these are the kind of real life problems which you as teachers have to look at, and then try to give it to your students, give a sort of solution and say, let them work on it. Now, this need not come as a full solution in one just end semester's group. What I'm trying to talk about, it can span about 3 or 4. So you need to plan ahead and ensure that all these things are available, especially the funding. When you talk about funding, you need to give it a minimum of 6 months to 1 year for you to actually get it. The more higher the funding, the more time it's going to take. So you need to do a big homework, and then once that is ready, you can always involve your students in a very, very meaningful and a very interesting way. And I guess that's what even the students are probably looking at. It's not just some sort of a very obscure IEEE paper. They take some 3-4 papers and take some concepts. They make a khichdi, make a mix of all these things, and then again submit something of it, which is just again which is going to just make it a paper editing work other than anything else. So it's us as a teacher to expose the students to real life problems. To do that, we need to get exposed ourselves first by going through. And there are a lot of free events provided by semiconductor majors like National Instruments. If you take about electronics and some semiconductors, you take about Infosys webinars. They talk about lot of people in the industry. They come and talk about what are their experiences, what are the projects. So you need to attend. You as teachers need to attend and ensure that if something very much interesting is coming up, keep in touch with the person who has started or initiated that, and then introduce your students to those projects or those events, so that they will be able to follow and be in the next step than what they are existing right now. And another thing, what is available today, frequent, maybe for a few years down there, a couple of years, is there are lots of available items which are very, very difficult to get. Maybe about 10 years back, you just can't even imagine. There's no way you can get, because it will be available somewhere in China, somewhere in Germany, and somewhere in very special view. There is no chance for you to get it. Whereas today, all such things are available on the internet, just at the click of a button. You pay online and they get delivered it in your place. So you need to look out in your area what are the new products which are available in such sites like eBay, Amazon, and so on, so that you will get new ideas by going through those items, which I happen to get it. So that's why I'm just trying to share it with you. Just keep browsing what are the new products in your field of interest. I'm sure you'll end up with hundreds of projects, because you already have got resources. These are the things available using which you can solve a particular problem of which is in your area, or which is in your interest, or which is in your budget, and so on. And you have got internet. Again, you can use it for contests. For example, I attended a contest from Amrita TBI, which is called Pitch Fest. They conduct it every year, and I was fortunate enough to win that particular Pitch Fest 2013 for my idea of MCAP, which you're going to look at at a more in-depth today. So I would want many of your students, many of your projects to come up, see the world in such sources, and then you can take off in that way. And that's what. So you need to do a bit of work, keep the projects ready, tightened. At least you don't have to completely work, but you should have a plan ready, and ensure that your students are given that in a nutshell, that these things are the steps. So this 6 months you're going to do, next batch is going to take up the next, and so on. If such a plan of action is available, I'm sure it is very easy. It's going to be very much interesting both for you as well as for students who are going to join. And last, it's not that you always have to look out for projects. You can encourage the students to go through the same processes, and you will be surprised by the kind of ideas and the kind of projects which they come up. It need not necessarily be only in IEEE papers or ASM transactions on CAD and so on and so forth. It will just be from real life problem which they have seen, and they have got an idea to try it out, which I would like you to encourage, work upon, and bring out, see the daylight of their ideas. And as I've been crowing about, show the students the resources in terms of websites, in terms of items available, and they will be able to explore further and further till they reach a particular stage where they can really make use of it. And if possible, I would like small groups created in your institution, maybe who are interested in doing a real good, meaningful NSEM projects, but you need to catch them at the third year or fourth year, third year itself, so that some sort of this planning activity, discussion can go on. And when they do the real end time, it's not just the 6 months. They would have started way back, way before the NSEM project time which has come, and really it's going to be a very, very phenomenal effect or output which you can reap if you can take such exercises. And of course, Google, you can't just live without it at the moment. So you have got everything, whatever is required, how to do it, tutorials, do it yourself, and so on. The whole world is opened up for you. All I would like you to do is just pick out which is very good, which is the best for you, and which is possible for you, and take those things and give it to your students. It's like, transforming big 13 kVA cut down to 230 volts, and then cut down to 12 volts, and then give it to students. Like that, you can just chop off and just abstract it, and then give in small dosages which can be absorbed by the students, and they can in turn make the tick clock going on. And the most important thing is you need to network with like-minded people and groups. That's why I say you form a small group, and you can see such groups existing in your neighboring colleges. In other, if you can see on online, they'll be opening up a lot of memberships, or they'll be calling you to collaborate, participate. So you need to encourage yourself and also put your students onto this, so that now you can go to the next level very easily. And project reviews, to do that, all these things, it takes, you don't have to make a very strict, rigid, that you have to submit some 10 pages of review and so on. It can be some sort of an informal, but at the same time it has to be very, very diligent, and the spirit must be maintained. The students must enjoy whatever the work, the problem they are working on, to do their work. The slog which they have to go to, they must really love them. That is, you have to make them that way, feel that way, that it's not just a sort of a rigmarole, run-of-the-mill stuff which they have to do just to get their degree. Instead of that, you must inculcate that they are engineers, and they are trying to provide some sort of a solution to an existing problem, and motivate them, so that the spirit is maintained in the engineering, in their end-semester projects. So now these are a very few snaps which I could take up. It's not mine. Many of the things are done by many of our group, many of our friends. The first thing what you see is just a very low cost smart class system. Today smart class, they are available at 60,000, 70,000 and so on. Whereas what we could do is, to the projector we attached a small Y remote. You can hopefully, I hope you can see the mouse. So this is a small Y remote which is useful. Y stands WII, wireless infrared remote. So using that, we have a very small infrared LED attached to a pen-like device, and you can write on the board, click, and all that stuff. The entire thing, I took it from a TED Talk, TED. I hope you are all looking at innovations in TED Talk. You have got a small 10-15 minutes video presenting their output. So I'm sure many of your students, and wish many of your students' output come in such forums or some such forums, so that so many people will get benefited in this. So this is what one small project we implemented at Wales University. We put it in about 6 classes, so that a lot of teachers are using it and finding it very useful to explain and so on. So the cost, like smart class, we need 60,000, 1 lakh and so on. It's not necessary. We can do the whole thing set up in a very few thousands of rupees. So that is where the cost effectiveness, the innovativeness which comes across. And here, this is a small micro windmill. We have put it on top of our college. So it generates something like about 750 watts, which is sufficient to run a today computer for about 4-5 hours a day. So it charges for about maybe 6-7 hours, and you can read the power for about 4-5. That's the kind of an output. So these are the kind of project ideas which I would like you to do. It involves electrical engineering students, it involves mechanical engineering students, so it involves civil engineering for electing. There was a big, so I called all of them, asked them to give them an idea. So they all involved very, very enthusiastically and connected. So that is the kind of interdisciplinary work which I would like you to move upon a quick start. Now this is a project which is done by my friend. He's very good at, he's a chemical engineer, and he has got a lot of solutions on enzymatic catalytic reactions. Now this is a project which actually converts organic waste. What I mean organic waste is waste from hotels or households, which is no vegetables or food stuff which is left, which are left over and so on. So you just put it in that container, and in about first 20 days, I guess you don't get any output. But after the 21st day, you continuously get biogas. You can extract ethanol from it, ethyl alcohol from it, which he is converting it into petrol, which he is able to run this kind of, and from this he generates power because of the steam which comes up. He generates power. So that is the kind of project, small project which he has implemented. He is a consultant for many industries, and he does this. Now, as a teacher, can link up with these kind of individuals and ask your students to participate in small level, in small incremental level, and you can see that their knowledge will get expanded phenomenally, and at the same time we can churn out many products in our. Now this is again done by this person. He is Dr. Krishna Kumar, and it is an anaerobic activated sludge reactor. So what he has got plans is even industrial effluent is available, which you can make use of it, which you don't have to pay anything for it. All you need to do is just make use of it in a better way. And we have got another tool. I would like you to show a screenshot of that for a minute. So I'm sure you would have seen a Moodle this thing. This is what we are looking at. So I have added a Moodle authoring tool so that anybody who's registered, they can have a look at this. It will basically tell you how to add content, how to create your own links, and how to put resources to your students and so on. So anybody who is interested, they can just email to me, gauri@mastersolutions.co.in, and I can create an ID for you, so you can create individual projects for your students, and you can ask them to link up and then take it up next forward. Interactions need not be just limited to email. They can have these kind of collaborative tools wherein you can take it up to next level. And there is another tool. What I'm talking about is a big blue button, which actually is a collaborative tool which allows both audio and video get connected to a group, a set of people. Like for example, if you look at a scenario wherein your students, a few of them are in different states or different cities, they all can be assembled in one particular place, like we have assembled here. And this particular tool will allow you to collaborate both audio and video, and it has also got a whiteboard facility, so that you can, whatever desktop you are having, it can be shared, students can talk, raise questions, and so on. And even this tool is available free. That is, any interested teacher who wants to conduct or who wants to organize a group or conduct a review or whatever it for them, all you need to do is just mail me, and we can take it up. I'll go back to the slide where my mail, it's taking a bit of time, so instead of wasting for it, we'll go back to the presentation. So you can mail me on gauri@mastersolutions.co.in for an ID in these two. I mean, I expect you to just play around with it. You don't have to really start seriously using and so on. You can just get yourself acquainted, like what are the tools available, and who knows, if you are in a computer science stream or a program ECE background, you might come out with better solutions which can be added to this, which is going to make it even more powerful. So that is the kind of, your ideas are most welcome. In fact, I'm working on different other ideas, like electric two-wheelers, whether we can see the range today is about 90 kilometers, whether we can extend it to 200, 300 by making use of efficient batteries, by making use of efficient charging system. I try to put a small dynamo in front, which will be able to charge up the battery sets which are available, and so on. So I want your students as well as yourself, imagine, go to some real world problems and see whether what is possible what can be done by you. And we like to go a little bit in depth in one of my pet projects, that is MCAPD is what I have titled. It is a mobile continuous ambulatory peritoneal dialysis. So now dialysis is required for patients who are unfortunate enough to lose both their kidneys, or whose kidneys have failed their function of extracting the toxic content in the blood and passing it out as urine. So if they have lost their kidney, the only way for the survival is getting a transplant. Somebody else must be able to offer them kidney, donate them kidney, and they will be placed surgically for the patient who have lost it so that they can continue their life. But unfortunately, not even 1 in 1,000 get such transplants, and even if they do get, there are a lot of questions regarding their survival, their efficiency, and so on. So the only survival option available is for them to go through a dialysis. Now dialysis, the main dialysis, what we all know about, is called hemodialysis. That is, blood will come out of our body, will be pumped out of our body, go through a filtering mechanism wherein urea, creatinine, these are the major toxic salts which has to be removed from the blood, cleared, it will be filtered, and then the blood again will be pumped into the body. Now to do this hemodialysis, patients have to go to a hospital, stay there for half a day, because this dialysis will take about 2 hours or 3 hours depending on the patient's condition. So like this, they have to do 2 times or 3 times a day depending on the patient's condition. So now you imagine what kind of a lifestyle the patient will have if he has to go to 2 or 3 half a days in their week to a hospital and then go through doing nothing. And not only just a travel time and this thing, it will be a big break from his service. Suppose he is working in some banks and some normal like us, when he is not able to do, his lifestyle will be totally crippled. So as against this, there is another form of dialysis called continuous ambulatory peritoneal dialysis. Now peritoneal dialysis, in our body part, we have got a cavity called peritonitis. Now on one side of the peritoneous wall, blood flows through. Blood from all the parts of the body flows through it naturally. Now what happens is, the peritoneal wall will act as a membrane, and what we do is pump in a highly concentrated glucose solution into the cavity. Now what we do is we surgically insert a tube, make an operation. One end of the tube will be inside the peritoneal cavity and one end of the tube will be outside the body. So now I thought I'll show you the picture. Yeah. So this is something like an abdominal cavity, and now what happens is, the dialysis, we have a highly concentrated dialysis solution. As I said, it will be in a bag which is about 1.5 liters. So just like the gravity, you connect it in a higher position through a stand and open up the tube which is connected. There will be a small tube which you can lock and then open up or close it. So fluid from the higher position will go into your peritoneal cavity. Now you have to retain this fluid for 4 hours in your body. That is called dwelling. So if you retain it for 4 hours in your body, because of the concentration difference, the peritoneous wall acts as a membrane and all urea creatinine will permeate from the blood into this particular fluid. Now after 4 hours, what you do is, you do a drain. Now you close the connection from the top and you open up the connection which leads to the bottom tube. What happens is, the fluid from the stomach comes out, and this fluid, the drain fluid, you will dispatch it in a restroom or any toilet or anything like that safely. Now this particular process is a CAPD process, a fill process, the dwell process, and the drain process which we have just seen. This has to be done 3 times a day. So every 4 hours you have to go to a place which has to be highly sterile, because what happens is, there is a tube which is directly going into your body, and if you expose it to external environment, it can very easily catch infection and you get up into peritonitis. There is a disease called peritonitis where the walls of the peritonitis will get infected. So now this has to be done in a highly sterile environment, and the patient, before touching these tubes, he has to undergo an elaborate procedure of cleaning his hands with soap solution and so on, and then do this particular process. So the objective of my project is to provide the patient a normal lifestyle where he is offered, when he is affected by the dialysis, where he will be able to do dialysis anywhere, wherever he is. Either he is in college or he is in a career, he is in office, workplace, and so on. And my other objective is, it's not only going to be anywhere, anytime, aware, but it also has to be very, very affordable, because this dialysis, he has to continue till his lifetime, till he dies. So the cost per month, currently the cost per month for this particular treatment will be about 15,000 to 18,000 rupees per month. Imagine how many people will be able to afford to undergo such kind of activity. So my idea is to ensure that it is reduced at least to some 4,000, 5,000, so that more people will be able to manage even if they are afflicted with this kind of disease. I'm sure even 4,000, there are so many people who cannot afford. Maybe we'll look at them at a later point. But right now, at least if it can be brought down to, so that many people can be covered into the dialysis, so that their lives can be extended. And another thing is, there are no proper dialysis machine in our rural areas. Maybe metros they'll have, and even there's a great demand going on. And tier 2 cities, yes, you will have very few where there will be great demand, or there won't be any proper effective dialysis centers. But you think about small villages where people get afflicted, they have to travel all the way to these tier 2 city towns and cities or metros and get their thing just for survival. So instead of that, my idea is ensure that they can do it wherever they are, in their homes or in their offices, colleges, wherever it is. So that is another objective. Is there are something like auto cycler machines which can do this automatically in the night time, but I am trying to provide a cost effective alternative which is going to be 1/10 of the cost available of whatever is existing in the world. So these are the kind of objectives which are clearly laid down for my problem which I have taken. So I would request you also to analyze the problem and ensure that what are the points which you are going to address, and once you have taken, what are the ways and means to go about it. So you can see a picture. The need is to create an affordable and accessible healthcare device for dialysis. It is estimated that there are about 1 lakh patients added every year, and about 2 lakh patients are waiting in Chennai alone for getting their dialysis done. You can see the volume kind of people suffering for want of getting dialysis done. So the idea of MCAPD is, as I summed up, bring life into their lives, is my motto of bringing out this particular product. So this is a rudimentary picture of what I'm trying to conceive, or what I've almost 75% of it is over. So you can see that my device is a wearable device. This is a belt which can be worn in your waist, and this is the device what I'm trying to create, which will take care. It has got an embedded controller, and it has got a peristatic pump which will do the pumping in and pumping out. It can change the direction, it can change the speed according to the control or according to the command program residing in the microcontroller. And what happens is, there is a sterile connector which we have created, which we have designed. This is going to take care of ensuring that there is no infection, even though this dialysis happens anywhere outside in the external environment. And this is the bag, which fluid bag which we saw hanging on the stand. We can either connect it in the waist itself through a Velcro strap, or you can have it in a military bag and just put it on your bag when you're traveling or when you're moving around or anywhere. So I'll just show you pictures of what is available. So this is a small box of prototype. It is in a very crude stage, but nevertheless it can do the job. So this is the battery what we have taken. These are some buttons. Actually, we are going to, in addition to these button interface, we are going to have a smartphone interface where all these button controls like start, stop, or record, or anything like that can be done through a smartphone. And with the help of smartphone, the advantage is you can even have a patient monitoring system where every dialysis log is recorded, and it can be sent to your doctors in case the dialysis quality is very bad and cannot do, and so on. So you can see how a simple idea just keeps on extending and building if you sufficiently think about it and sufficiently talk about it to various people. I've talked to many doctors, I've talked to many NGOs who give dialysis, I've talked to many patients. So that is the effort which you have to do, even though it's a student project, it's only a 6-month project and so on. You need to conceive it in such a big way so that these for example, a small MBA group can take care of the survey of this particular product. One group can go to nephrologists and see what is the problem. One group could have gone to patients and see what are their pain points and check out. So these are the ways which probably I have done. So I would request you also to take up student project in particular way. So we'll just go back to our next picture, the peristatic pump. And this is again an innovation or an invention made by in-house by my team and my friends. So actually peristatic, what happens, this is the tube which comes out from the body, and this is the tube which goes to a fluid bag, or the fluid which you're going to pull. That's what I call a CAPD fluid. So you can see 3 rollers rotating, and they're pinching this tube against the wall. So according to our Bernoulli's principle, what happens is once it is pinched, the fluid, the air gap will suck the fluid inside from here, whatever be the fluid, and keep passing it out. So that in no way this fluid inside will get in contact with any of the pumping mechanism. So such a device is a peristatic pump. So this is available world over. A lot of people are doing it. But what we have achieved is It's a micro miniaturization what we have done. Our peristatic pump you can just open up this latch, it will slide out, you can just connect this tube, because in our case the patient has to put one tube every day, so that at the night when the dialysis is over, when he goes back home, he has to discard this particular sterile connector what we have to. So we need a mechanism wherein the patient can insert it automatically and easily. So this is something which we have thought about over many months, and there are many inputs from many students and many working professionals, and they have got it out at this level. So, sterile connector. So this is again a rudimentary drawing of a sterile connector idea, and this is what we have done on our own, hands-on. So the idea is, this is a cap which the patient has to remove it by touching it, open it, and this end of it he has to connect it. There will be a screw-like thread available here, which he has to bring it up there and then connect it, so that the fluid from the bag will go into the peritoneus, or the fluid from the peritoneus will come out into the drain bag. Now, doing this anywhere outside is going to create a big problem because of the infection. You are not even supposed to touch with your open hands this particular portion inside this cap. So that what we do is put inside this like plastic like thing, so that on the plastic cover you operate, you open it up, close it, connect it, so that you are avoiding the risk of your hands touching that particular very sensitive portion and getting infection and so on. So that's how we beat infection. Now this particular tube we have patented it, and I'm awaiting patent for it. So you can see very big, very complex situations or problems can be thought about in very simple terms and simple solutions, it out about like this. And the fluid bags, of course, this is some demo which we have shown somewhere. So the fluid bags are something like this. One of it is connected, and these are our small microcontrollers, and these are the switch what we saw. And this is the one version previous. Now our current version is a 1/4 of what size you are seeing here, and it can still do the job of pumping in and pumping out of the predeterminants and so background and a bit of computer science background. That's it. So now what happened is, I went through so many multidisciplinary people. Of course, I had the fortunate fortune of talking to various people who are doing CAPD, and then trying to talk with them how to go about it, what are their pain points, and so on. So what I would request you as teachers is, just keep on looking at problems what is available. Of course, there are plenty in our society, and try to look at positive way of finding solutions and contributing solutions for their problems, which will definitely help you, identify so many projects, small projects for the students. And of course, the IP, we have patented for the miniature peristatic pump, we have patented for sensors what we have used, and we have patented for the sterile connector what we are talking about, and so on. And the advantage what we have got is, as I tell you, I want to keep it very low cost, 1/10 of existing, and it's going to be very easily used by people who are not even literates. The system will take care of automatically the pumping in, pumping out, alerting the patient something is wrong, and so on. So the patient intervention is kept to a very minimal in these issues with this MCAPD. And the impact is, it's going to lift the spirits of the renal patients, because the dialysis will happen automatically. They don't have to go back from their jobs or from their colleges or schools, and they can still survive properly without any. So these are the kind of outputs or outcomes of what I'm trying to do. So what I had taken is something like design and development is something like for for 2 months, for especially peristatic pump and sensors, and design and development of control circuits I took a 2 month, which went on parallelly with different set of groups of students. And fabrication of belt and latch mechanism what you're trying about, it's still going on. It's not that we have come to an end stage, it's an ongoing process. And we are trying to do an integration and testing with our guide, Dr. Rajan Ravichandran at Mayat Hospitals, Chennai. And once they are through, what I would like to do is take the approvals and certifications from different entities. Like approvals I have to take from medical device regulation authorities, and certifications I would like to have CE certifications, ISI certifications, and so on. And once I'm through, I'm ready for commercialization of it. So I've taken up from a small student level project up to a commercialization, which is this particular product. I'm very proud and very happy to say it's nowhere available in the world. So that is the kind of vision I expect you to have, and it's not just for bragging. I would like you to think on those lines. You have a vision which is going to be very broad, very open, so that so many things can happen. So this is a news item which says Chennai has got a lot of kidney problems. 2 lakh people patients wait for this thing, and so on. And so now we are really there are any questions or anything about what to and so on, I would really like to answer it. Hello, any questions? Nothing of that sort?
One question, sir. Any special by innovation in project work?
Any special? Come again, sorry. See, what you have to do is we should look at results and not IEEE papers, first step. Because IEEE papers start at a very high research level, which you don't get everyday innovation, which is the need of the hour. So what I would like you to do is go through DIY, do it yourself project, look at contests, to address. If you take up that as probably, I'm sure not papers end up in IEEE journals. Did I answer you? Does that give you some sort of a
Question on the same
yes, sir?
that's it. How in my entrepreneurial skill students?
Exactly. That's the $1,000,000 question. Everybody too small. No, what we need to do is we need to have some sort of a safety net for these students. I myself, I did my MS entrepreneurship at IIT Madras, and for basic job for a student, just take a job and goes up. So on day one himself, he'll be provided with some money. And he can take himself and so on. Now, what we need to do is offer some such stipend or some sort of incentive for students first to pick up and ensure that they can sustain their pay or they lay off or they are not financially. So, investor and so on.